Okay, today's lesson is about the properties of parallelograms. So we're going to use these relationships to see the sides and angle relationships of a parallelogram and also see what happens with the diagonals of parallelograms. So you have to understand that parallelograms will have special properties regarding their sides, angles, and diagonals. So first of all, you have to know your definition of a parallelogram, which is a quadrilateral with both pairs of opposite sides being parallel. So remember way back in August, I taught that the red arrows or arrows on the line indicate that lines are parallel to each other. So I know that if I label this parallelogram A, B, C, D, I know that A to B is parallel to C to D, and I know B to C is parallel to A to D. I know that because that's the definition of a parallelogram, that opposite sides are going to be parallel to each other. In a quadrilateral, opposite sides do not share a vertex and opposite angles do not share a side. So you should see here in this parallelogram that A, B, and CD are opposite sides. So they do not share a vertex, and angle A and angle C are opposite angles. You have to know the symbol for a parallelogram, which is this little slanted square. Okay, if you see that, that means that the shape that you're looking at is a parallelogram. Now to go to the properties. So you have to know your theorems or rules for a parallelogram. So these are a bunch of if-then statements. The first one right here, if ABC is a parallelogram, how do I know it's a parallelogram? Opposite sides are parallel. Then I know that opposite sides are congruent. So again, if parallelogram, opposite sides are congruent, equal to each other. Also, we have consecutive angles in a parallelogram are supplementary. So here's rule number 2. So if you have a parallelogram, meaning opposite sides are parallel to each other, then I know that consecutive angles are supplementary. Consecutive means they're neighboring angles. So I know B and C is 180, C and D 180, D and A 180, and A and B are going to equal to 180. Rule number 3 for a parallelogram. If I know I have a parallelogram, opposite sides are parallel, then I know opposite angles are congruent, not supplementary. So again, A and C are equal, not supplementary. B and D are equal, not supplementary. And again, this is only true because you have a parallelogram. Next, if you have a parallelogram, the fourth rule states that if you have a parallelogram, then the diagonals bisect each other. So here, remember, a diagonal is connecting two vertices that are not consecutive. So A and C are non-consecutive vertices. So if you connect them, you make a diagonal. B and D is a diagonal. So when you intersect at point E, I know that B to E and E to D are equal, and A to E and E to C is equal. I'm not saying the diagonals are congruent, I'm saying the diagonals bisect each other. And then the fifth rule states that if you have multiple parallel lines, so A, B, C, D, and E, F are all parallel lines, then I know if AC and CE are congruent, then I know the opposite sides are also congruent. So looking at this diagram, notice that I have 1, 2, 3 lines that are parallel. I give you that these two are congruent. Then I know that these two are congruent to each other. I'm not saying that the blue tick marks are equal to the red tick marks. I'm just saying that the blue tick marks are equal to each other. And I'm going to summarize all this on the next slide. So you have to know these properties. You have to know opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles supplementary, diagonals bisect each other. So first rule for a parallelogram, I know that the opposite sides are parallel. So I'm going to do my best to draw my arrows. So here is number 1, right there. So this is rule number 1. That opposite sides are parallel. How do I know they're parallel? Because of the arrow marks. So that's rule number 1. Okay. Erase. So here is rule number 2. Rule number 2 says opposite sides are congruent. So I know AB and DC are equal, and I know AD and BC are equal. I know that because ABC is a parallelogram. So ABCD is a parallelogram. You'll also see me abbreviate parallelogram as pgram. So that's rule 2 of parallelograms, that opposite sides are congruent or equal. So let's do rule number 3. Opposite angles are congruent. So here's rule 3, opposite angles. So I know A and C are equal, and B and D are equal. That's rule 3, because it's a parallelogram. Rule 4, that consecutive angles are supplementary. So here is rule number 4. If this is 80, this is 100, this is 80, and this is 100. So I know that if you look at consecutive angles, these are consecutive, and they're equal to 180. These angles, they're equal to 180 because they're consecutive. These are equal to 180 because, again, they're consecutive. And then the last one, these are also equal to 180 because they are consecutive. So again, consecutive angles are equal to each other. And I also know that, don't forget, how do I know A and C are both 80? Because A and C are representing rule number 3, that opposite angles are congruent. So there's a lot going on in parallelograms. So let's go with the last one. Diagonals bisect each other. So if you have a parallelogram, so diagonals connecting non-consecutive vertices. So I'm connecting my non-consecutive vertices. Then I know that, I'll label this E. So I know DE and EB are equal. And then I know AE and EC are equal. And that's rule number 5. Diagonals bisect each other. So you have to study and memorize those 5 rules for parallelograms. And again, that's only the case if you have a parallelogram. All 5 rules are true. So let's apply it using algebra. So using the diagram, I have parallelogram ABCD. I need to find the value of each of the questions. So I need the measure of angle A, measure of angle D, I need the value of X, and I need to know the length of AB. So let's do the first question. Okay, measure of angle A. So I know that angle B plus angle A is equal to 180. How do I know that? This is rule number 4, consecutive angles. So I left the rules up top. So I know B is 127 plus angle A equals 180. So I know that 180 minus 127 is going to be 53. So angle A equals 53. Let's do number 2. So I want the measure of angle D, So I know that this is going to be rule number 3 because opposite angles are equal. So the measure of angle D is equal to 127. Now let's find X. Notice that X is representing the sides, so I know that X plus 2 is going to equal 2X minus 3. How do I know those two sides are equal? By rule number 2. Opposite sides in a parallelogram are congruent. So this is rule number 2. So to solve, I minus X from both sides, add 3 to both sides. Therefore, X is equal to 5. So question number 4, AB is equal to X plus 2. I know X is equal to 5. So AB equals 5 plus 2. So AB is equal to 7. Therefore, also CD is equal to 7. And that's how you use your rules of parallelograms to solve algebraic problems. Let's do another example. So here I have parallelogram KLMN. I don't know what KM and LN are. So notice that I have diagonals. So I know diagonals bisect each other. That means they're going to be cut in half. So I know that X equals Y plus 2. And I know that Y plus 10 equals 2X minus 8. This is from rule number 5, diagonals bisect each other. So since we have two equations with two unknowns, we did this back in September, linear equations. This happens to be a system of linear equations, substitution method. So now that I know that X equals Y plus 2, I can substitute it in. So I know Y plus 2 is for X. So I'm going to substitute it in. So I have Y plus 10 equals 2 parentheses Y plus 2 minus 8. Now I'm solving for Y. 2Y plus 4 minus 8. So I have Y plus 10 equals 2Y. 4 minus 8 is minus 4. I have to add 4 to both sides and subtract 1. So I add 4 minus Y. So I have Y is equal to 14. So next I resubstitute back in. So I now take Y and I substitute it back in. So I know X equals 14 plus 2. X is equal to 16. Now I can actually find the lengths of KMLN. So I have K to M. So I have K to M is Y plus 10 plus 2X minus 8. So Y plus 10, I know Y is 14 plus 10 plus 2 times 16 minus 8. So I have 24 plus 24. So I have 48 is K to M. I also want the length of L to N, which is X plus Y plus 2. And again, this is L to N. X is 16 plus 14 plus 2, which equals 16. 16 is 32, which is Ln. So this is a nice problem with review of linear systems equations. Let's try another one. So I'm going to apply rule number 5. Diagonals bisect each other, so I have X plus 1 equals Y. I have 3Y minus 7 equals 2X. Two equations, two unknowns. I have to do a system, which means substitution method or elimination, your choice. So I already know what y equals, so I know that 3, I'm going to take the x plus 1 and substitute it in for the y. So I have 3 times x plus 1 minus 7 equals 2x, solve for x. I have 3x plus 3 minus 7 equals 2x. So I have 3x, 3 minus 7 is negative 4 equals 2x, therefore x is equal to 4. If x is equal to 4, so 4 plus 1 equals y, so y is equal to 5. Now we can go about and solve for my lengths PR. So PR, or RP, let's erase this and get it right. So I have P to R. P to R is 3y minus 7 plus 2x, which is substituting in the values. Y is 5 minus 7 plus 2 times 4. So this is 8 plus 8, which is 16, which is P to R. And let's solve for the other side, SQ. So S to Q is equal to x plus 1 plus y. So I have 4 plus 1 plus 5. So I have S to Q, which is equal to 10. Let's use the multiple parallel line rules. So this states that I have 1, 2, 3, 4 parallel lines. I tell you right here, AE, BF, CG, DH are all parallel. I tell you A to B is equal to B to C is equal to C to D, and they're all 2. So multiple parallel line rules, okay, states that if I know that I have multiple parallel lines, I know that the transversal has congruent parts. I know that these are all congruent over here. So I know that E to F is equal to F to G, which is equal to G to H. And I know E to F is 2.25. So I know E to F is 2.25. This is 2.25, 2.25. I want E to H. So I want E to H, which is equal to E to F plus F to G plus G to H. So E to H is 3 times 2.25. So E to H is equal to 6.75. So that concludes the mini lesson on properties of parallelograms and a little review on systems of equations. If you have any questions, please ask during class. Here are 3 questions that you should try on your own.